Hello Internet! Today I have this fancy 3080 Ti from Zotac. This thing looks gorgeous and massive. It reminds me of another premium card such as MSI Supreme I fixed the other day. If you think about buying one, stick around. We're going to check and see if this thing is worth your hard working dollar. So let's take this one apart and see if the most important component in the graphics card, cooling design, is any good. We'll see how cooling performs near the end of this video, so be sure not to miss it. Here we are. At first, it seemed that the cooling solution is not too bad, with two exceptions. The electrolytic capacitors are left on their own, as well as the coils. That's not the best way to keep the card cool, but it's not the worst one either, so let's continue with the removing the backplate and see if we have thermal pads on the back. Great, we have pads under the memory chips, but no pads under the VRM area, which is not good. I guess Zotac is cheap, even when it comes to a nearly $2,000 premium product. After a brief visual inspection, I think I've found a bug. Or what's left of it after trying to urinate on a powered device. So I will remove its remains and clean the area for a closer inspection. Okay, so what I'm seeing here is a little bit of corrosion around this resistor. My guess is this resistor is no longer contacting the pad underneath, and it's probably the same for the capacitor that's right next to it. So I will remove them both and prepare the pads to accept new components. I don't yet know what that circuit is responsible for, and before we figure this out, let's do basic measurements, starting with several kilo ohms on 12 volt line, 3.3 with several mega ohms. These three are all 12 volt with several kilo ohms. This I believe is a secondary 5 volt with 14K. The main 5 volt rail with 1.7K. This here should be 1.8 with 1K. And a PEX with 3.5 ohms. And 40 ohms on memory, and nothing is shorting out, so we can power it on and see if we have any issues with voltages. My guess is we're going to have 5 volts here and the main 5 volt. Next in line is 1.8 and there's nearly nothing, explaining the purpose of the circuit in the back. Now let's trace what goes where. Poking around the old resistor area, I was able to determine which pin the old resistor was connecting to. And armed with that knowledge, let's look at a circuit of a similar card and see what value of a resistor we need that is connected to that pin. This is 1.8 volt circuit from a 2080 Ti, which is different, but it doesn't matter because the circuit is always the same, while the layout may be different. So I will look under a microscope to see a small dot on the chip that indicates the location of the pin number 1. From that, we count counterclockwise, and it just so happens this chip orientation is the same, but the resistor layout is different, but we don't care. The value remains the same, and it says 0 ohm resistor and a 0.1 microfarad capacitor or 100 nanofarads. So let's put those on and see if we get lucky today. Card cooled down. Let's check for resistances on 1.8 volt just to make sure we didn't create any new problems. Just under 1K, which is normal, so let's power it on and see if we get 1.8 volt now. There we go, we have 1.8 volt, and the card is now drawing 2.5 amps. Next on the list, we have 0.75 on the core, and 0.95 on the PEX, and of course 1.38 on memory. Great! I will now look at the board with the thermal camera just to make sure that none of the MOSFETs are heating up any more than the rest. And everything is looking good so far, so let's boot this thing up and see if we can get a picture, and maybe run a memory test while we're at it. Memory test has passed. That means there's no reason to wait any longer and put everything back together and run more tests. But before I do that, I would like to point out a serious problem I've found while cleaning the core. There are gouges on the mating surface of the heatsink. You can even see that the impression of the gouge is left right next to the letter G. A gouge like that can either crack the crystal of the GPU, or it will introduce an uneven mating surface, which would result in poor cooling. So what I'll do is I'll take the sharp razor blade and I will simply cut the head of that gouge, like so. Last time I saw a gouge like that on another card, I fixed that gouge and the card dropped 10 degrees, so let's see if we're gonna get good temperatures on this one. With that fixed, let's apply new thermal paste, complete the assembly, and run stress tests as usual. As you can see, the temperatures are very good. Hotspot is just on the edge of 75 degrees, which is very impressive. Everything else looks good as well, and I will continue with the heaven just to make sure that we don't get any glowing stars or flickering. Complete superposition benchmark to see the scores, and that should be it for this repair. Thank you for watching. If you need a professional repair at a reasonable price, please contact me by following the link in the description. Goodbye. And that's it for this repair. Easiest repair in the world. So I hope the customer will be happy, because his card is now fixed and it looks good and it works just as good.